Welcome back to Aurora Tech Channel. Today, I will be reviewing the BIQU Hurakan, which is the printer from BigTreeTech with pre-installed Klipper firmware. There aren't very many printers in the market that run Klipper firmware. I have reviewed two printers with Klipper firmware that can print really fast, or up to 400 millimeters per second, which are the BambuLab X1 Carbon and the FLSUN V400. And though I am happy with both of them, they are not cheap. The FLSUN V400 is a Delta kinematic printer that costs around $850, and the BambuLab X1 is a CoreXY with its base model starting at $1,000. The BIQU Hurakan only costs $369, which is much cheaper. This printer is a Cartesian bed slinger with some basic hardware that allows you to start using Klipper firmware right out of the box. The hardware cannot compare to printers in the $1,000 range, but let's take a look at what it does come with. The major feature of this printer is the BigTreeTech Manta M4P motherboard with the CB1 as a Raspberry Pi replacement to run Klipper firmware. The M4P motherboard looks slightly different from the retail version, but they look pretty much like the same board, just with different colors. It also comes with 4 detachable TMC2209 stepper drivers. It has some features that are similar to an entry-level printer, including a single Z-axis and a Bowden setup. There are also some mid-range printer features, such as a dual-gear metal extruder, a dual-part cooling fan, a double-sided PEI textured spring steel print surface, a BIQU auto bed leveling sensor, a filament sensor, belt tensioners on both the X and Y axis, an LED light on the print head, and there is a switch on the heated bed that allows you to only heat the center, which means you can save electricity for smaller prints and also heat up the entire bed for larger prints. The printer comes with a tiny LCD screen. We will use the web interface to control the printer most of the time, but you can still use the screen to do basic operations like homing, preheating, bed leveling, and starting a print from the SD card. I would like to thank BIQU for sending me this machine to review, and with that, let's get started. We have the base, the gantry, the X-axis with the print head, the LCD screen, a power cord, an Ethernet cable, a filament holder, and some tools. I will start by removing the Z-axis stepper motor and the lead screw from the gantry, sliding in the X-axis, and then putting the Z-stepper motor and the lead screw back. Next, put the gantry on top of the base, and tighten 2 screws on each side. Then, mount the screen at the right side and connect 2 ribbon cables from the base. Mount the filament holder, connect the cables for the Z-axis, the extruder, the X-axis, and the ribbon cable for the extruder. Use a coupler to connect the Bowden tube from the extruder to the print head. Before I turn on the printer, I will take the microSD card out and take it to my computer, as the operating system is Linux. It shows 4 drive letters on my PC that aren't accessible for Windows apart from the last one. I will open the system.cfg file, enter the SSID and password for my Wi-Fi network, save it, put it back, and I can now turn on the printer. After 30 to 40 seconds, it shows the main screen. Go inside the menu, scroll down to the bottom, and it shows the IP address of the printer. For some reason, it does not show the IP address every time, but you can always log into your router, and you should see a device called Hurakan if it is connected to your network. Or you can use programs like Angry IP Scanner to find your IP address. Let's open the web interface, which is a standard mainsail Klipper web interface. Let's go to the G-code files and start our first print to ensure that everything is working. It's now printing a 3D Benchy, but this Benchy is larger than a standard one. The speed is similar to a normal speed of 50 to 60 millimeters per second, and this large Benchy finished in 2 hours and 26 minutes. Compared to a standard Benchy, this is about 30% larger. The layers, cooling, and overhanging all look fine. There wasn't any fast printing, but this does at least tell us that the printer is working normally. Next, I will go to Cura and slice my own models. There is no profile for this printer, and the manual suggests to just use the BIQU B1 profile, but I will create a custom FFF printer profile instead. I just changed the print volume, checked the heated bed, changed the filament diameter to 1.75, and left the rest of the printer profile unchanged. For the print profile, I created a few profiles for different speeds from 60 to 180 millimeters per second to test it out. I used 215 degrees Celsius for the nozzle temperature, as printing at a higher speed also requires filament to be melted faster. I also set the heated bed temperature to 70 degrees Celsius as my garage is cold, and the room temperature is only around 16 to 18 degrees Celsius. As for the speed, I set the fastest one to 180 millimeters per second, so the printing infill and the inner wall will use 180 millimeters per second. The outer wall, as well as the top and bottom of the print, will use 15% of that speed at 90 millimeters per second, and the first layer will just use 40 millimeters per second to ensure that it sticks well to the bed. For acceleration, I used 3000 millimeters per second squared, except for the first layer. I also left the small feature speed as 25% inside the experimental settings. To enable the Wi-Fi printing feature in Cura, you need to install the Moonraker plugin. I already have it, as I have other Klipper firmware printers installed. Inside the plugin, you need to put the same IP address as the printer so that Cura can communicate with the web interface. You can also choose to enable a thumbnail if you want. For the monitor, I didn't plug any webcam in the printer's USB port yet, so I will just leave it. Let's slice the model and upload this 38-minute Benchy to the printer and start the print. It is now starting at 40 millimeters per second to print the first layer. It still looks faster than a standard 3D printer, as when you print at 50 millimeters per second on an Ender 3, it will print the first layer at 25 millimeters per second. After the bottom is finished, it starts to increase in speed. It looks pretty fast, but as you can see, the standard cooling fan may not be able to keep up with the speed, so there are some cooling issues, but I will just let it finish and see how it turns out. The print took 45 minutes to finish, and it's actually not that bad. The cooling is not great, the overhanging is alright, and the surface has ringings and isn't very smooth, but this is expected when a bed slinger prints at such a high speed. As this printer did not calibrate the input shaper at the factory, I will use the accelerometer to do some calibration and see how we can improve the print quality. I will home the printer and start with the X-axis. I secured the accelerometer using one of the part cooling fan screws, and it started moving the print head to generate some vibrations. When you go back to the console, you can see that it's testing out different frequencies. After a few minutes, we can use the save config command and save the values. Then, we can move the accelerometer using one screw on the heated bed cable connector to secure the sensor. Home the printer again and start the Y-axis calibration. It's going to do the same, and after a few minutes, we can save the values, restart Klipper, and print another Benchy at the same speed of 180 millimeters per second to see if there are any improvements. The print time is the same at 45 minutes, but there are some improvements on the ringing, as the surface looks a bit nicer. However, the cooling still isn't good, as this is beyond what tuning an input shaper can do to help. We need to reduce the print speed and hope the stock cooling system can keep up with the lowered speed. I tried printing at 120 millimeters per second and 100 millimeters per second to compare the results. These are 4 Benchys printing at different speeds, and of course, the 60 millimeters per second one looks pretty nice. It's the same as Benchys printed by other standard 3D printers, and the 100 millimeters per second with 1500 millimeters per second squared acceleration also looks good, with no obvious quality decrease at all. The 120 millimeters per second with 2000 acceleration is acceptable, but I definitely won't print at 180 millimeters per second unless it is just a fast prototype. As for the cooling, both 60 and 100 look good, although it starts to show some issues when printing at 120. But depending on your model, it should still work on most prints. For 180, it only shows the printer can move and print at this high speed, but the print itself may not be usable. So it seems that for this printer, 120 millimeters per second is the maximum printing speed with presentable quality. Before doing more test prints, I would also like to calibrate the pressure advance. I will start with the standard 60mm per second calibration cube, and as expected, the overshot corners are similar to most printers that run Marlin without tuning linear advance. The overshot corners show on the X, Y, and the flat surface. I will use the square tower model from Klipper's official website to calibrate the value. First, I have to slow down the square corner acceleration by copying this command to the console. As this is a Bowden setup, we will use 0.02 as the tuning factor. Copy the command to the console as well, and we can then slice the model with Cura. To save some time, I will set the infill to 0%, then upload the file and start the print. The bottom is not using pressure advance, which will increase the value, so the top will be using maximum pressure advance. I think the sweet spot is around this area, or about 35mm. Multiply this number by the factor of 0.02 we use for tuning. I will just open the printer.cfg file, as it includes another CFG file for this Hurakan printer. I will open another config file, go to the extruder section, and add pressure advance equals 0.7. I will print another calibration cube to see if the corners have improved. It looks much better, though it isn't perfect, but I will just stick with these settings and do more test prints. I then printed a fidget spinner to test the clearance and see if it is accurate when printing at a high speed. The spinner finished printing in 1 hour and 40 minutes. The print looks alright, and it's also functional. Then, I printed a model of the Titanic, but I forgot to switch the heated bed, so it just heated the center of the bed and the print worked. Additionally, as this long model can warp easily, I also applied a thin layer of glue when I restarted the print with the full print bed heated. The print does not look bad, but the front is still warped. Besides that, the details on the top still look nice. This print took 3 hours and 48 minutes, and if the same time was used on a standard 3D printer, you would have been able to print 2 Benchys, which isn't bad. Next, I will print a GG cap. I added a raft as the front legs are easy to break, and it will be easier for me to remove the print without damaging it. The print only took 1 hour and 37 minutes to finish. The body and the top half of the head look fine, but the lack of cooling shows again on the bottom half of the head. After that, I will print a model of a Bitcoin cat. Take a look at the web interface, and once printing at 120mm per second, the flow of the hot end is 10.6mm cubed per second. Generally, a standard V6 hot end can flow up to 12 to 13mm cubed per second. So printing at 120mm per second would require a flow of just around 10mm cubed per second. This Bitcoin cat looks good, with no cooling issues, as it doesn't require as much cooling as the GG cat and the 3D Benchy, and the texture of this model also hides the layer lines well. Then, I will try printing with some PETG. Generally, PETG should not be able to print at high speeds, but I will just start printing this trash can at 120mm per second and see what happens. As expected, we have some extrusion issues, so I will reduce the speed to 80mm per second and reprint this model. As I'm using vase mode, the first layer and the bottom will only print at 40mm per second, and the walls will also print at 40, but it is still faster than the standard 50mm per second, as it will print at 25mm per second for the bottom and the walls. This trash can took 1 hour and 27 minutes to finish, and it looks perfect. I can't find any problems with this print, even after zooming in. Following that, I will print some TPU leg pads from my IKEA end table. I've used the same 80mm per second speed, which means the infill is printed at 80. It looks like the extruder can also push film in fast enough to keep up with the speed, and the print finished in 52 minutes without any issues. I then printed another 3 at the same time, and they also look fine. Next, I will try to print a set of shelf brackets with ABS. As ABS can print at the same speed as, or even faster than PLA, I will speed it back up to 120 millimeters per second. This set of brackets finished in 2 hours and 17 minutes, which is more than 2.5 times faster than a regular 3D printer, which normally takes 6 hours. Finally, I will print a model of the Chrysler building and print the same model on an Ender 3S1 to compare the speed and the quality. As you can see, the Hurakan completed the print in 4 hours and 44 minutes, while the Ender 3S1 kept going and ended up taking 8 hours and 7 minutes to finish. Of course, the building printed by the Ender 3S1 looks a bit nicer, but the difference isn't that obvious other than the tip of the tower. However, I think the rest of the building looks fine. As you can see, most prints have been printed using 120 millimeters per second except for PETG and TPU, and they're all still fairly presentable when being printed at this high speed. Let's talk about the pros and cons of this printer, starting with the pros. 1. The Klipper firmware is ready right out of the box, but you still need to calibrate the input shaper and pressure advance if you want to get better print quality. However, this machine is still the easiest option for anyone new to get started with Klipper. 2. It prints fast and prints pretty well at 100 millimeters per second, and most prints are still presentable when printing at 120 millimeters per second. 3. The power-saving feature of the heated bed is nice. You can choose to heat up just the center of the bed or the entire bed, which can save electricity. But it could be better if it uses G-code to control the heat zone, like the WizMaker P1, other than to toggle the switch manually, as you may forget to do this once in a while and cause the print to not stick. 4. The hot end is a big surprise. When I opened the printhead to see what was inside, I saw the Bowden tube in contact with the heat break right in the middle of the heatsink, instead of touching the nozzle inside the heater block, so it's an all-metal hot end. However, you need to change the maximum temperature to be slightly higher if you want to print at 275 degrees Celsius, or else the printer will trigger the maximum temperature shutdown at 275 degrees Celsius. I tried to print with nylon carbon fiber at 275 degrees Celsius and ended up with very good results. I also tried to print with polycarbonate at 285 degrees Celsius. This didn't turn out as good as nylon carbon fiber, as the PC filament required an even higher temperature, but it was still okay. After the high temperature prints were finished, the Bowden tube was still in good shape, as the contact point of the tube and the heat break is inside the heat sink, which should be way below its melting temperature. For fast printing, using a Bowden setup may be the better option unless your direct drive extruder is very light. Now for the cons. 1. This printer is a mid-range printer in terms of price. It runs Klipper and comes with a better motherboard, with the CB1 as a replacement for the Raspberry Pi, but the rest of the hardware is not as good as other mid-range printers. For the price of $369, I would expect it to come with a dual Z-axis. 2. For now, the user still needs to calibrate the input shaper and pressure advance manually to get better print quality. Instead, BIQU could pre-calibrate these at the factory and put a set of default numbers for all printers. I do understand that the result for every printer may be slightly different even if the hardware is the same, and when you use different brands or different types of filament, the pressure advance value may also vary. However, I was using the same set of values for all of my test prints with different filaments and all, and I'm still okay with the results. So, having a set of default numbers is still better than not calibrating the input shaper and not using pressure advance by default. My other Klipper printer, the FLSUN V400, didn't come with an accelerometer and just used the default numbers they put inside the firmware, but it still works fine. So, BIQU could consider adding these values, especially as it would cost nothing and wouldn't make anything worse, as most users should print better right out of the box, even with those default values. In conclusion, this printer is the easiest way to get started with Klipper. There are no more overpriced Raspberry Pis from scalpers, no more Linux command line configuration, and no more firmware flashing. This printer just prints right out of the box, and with some simple calibrations, the results are pretty good, even when printing at 120 millimeters per second. Surprisingly, it came with an all-metal hot end that BIQU didn't mention as a selling point, so it can print nylon carbon fiber and other high-temperature filament. Of course, if you plan on printing PACF frequently, you would also need a hardened steel nozzle and upgrade to a better thermistor. But overall, this printer runs smoothly and did meet my expectations. Additionally, I think BIQU is a bit conservative to advertise their recommended printing speed to be 60 mm per second, as no one wants just a 60 mm per second print speed with Klipper. I have seen other bed slingers use the same rubber wheels for the motion system, claiming to have a 250 mm per second print speed, which sounds way too high, but I would say the normal print speed of this printer can definitely reach 100 to 120 mm per second at 1,500 to 2,000 mm per second squared acceleration with presentable print quality. Though in my opinion, being a little careful is always better than making skeptical claims. Anyways, if you are interested in this printer, I put the link under the description. That's it for this video. If you like this video, please hit the like and subscribe button and click the notification bell to receive new video updates. I will see you next time.